So Rachel Bodeker sent me an email saying that she can't be here this week because she's taking an optics class right now, which meets at this time, and she's trying to find a different class so she can come to this time instead, but she hasn't done that yet. So she asked, at least for today, John Gibbons and I to run the meeting, and then hopefully we'll get things sorted out with course schedules in the next week or so. John, did you get the agenda from her?
Oh, got the Telecon reminder. No, I did not.
Let me see. Grape minutes. I have. Okay. I have the 7-page document. Okay, this is the one from a long time ago. Because I know she has it on Google Drive.
Yep.
And yes, Gary?
Excuse me.
If
I
I
found a
can't-
link to it last night. I think it's wherever she posts the meeting notice on the Google group.
Right.
Oh, okay. Right. So let me see. Yogi. Campsite. Right. Ah, yes. Perfect. Yep. Okay. Great. So, all right. So I have the agenda here, and I might like to something else.
Okay,
There.
show me that radio first.
Which radio?
On the very first screen. Before you get
Okay.
to the
Probably your Windows screen.
This?
yeah. What is that?
Oh, this. So I was playing around with artificial intelligence. And so Adobe, the Adobe company, they have a product called Firefly, which is an image generator that is supposed to like compete with ChatGPT's image generator and that sort of thing. And around
Yeah.
Thanksgiving, I asked it to make me a desktop background that showed like Thanksgiving, a ham radio Thanksgiving, and this was what it came up with.
Uh-huh. That is amazing. Thank you.
That's the ham.
You're welcome. I will take a minute. I want to show a few other photos. We had the walkthrough to close out our new ham radio installation yesterday at the university, so I can show a couple of images here. So it was like 10 degrees outside. We're up on the roof, but there's our new tower and our new beam. And this is one of the masts for our fan dipole. And you can see it has this ratchet mechanism down at the bottom for tensioning the dipole.
Nice.
And then, let's see. So this is the roof. This is the VHF, UHF section. So over here, this is the 6-meter vertical. There's a 6-meter horizontal loop. Here, I think this is the 1.2 gigahertz vertical. I better label these things and make sure I get them right. This is a 2-meter vertical. That's the 440 vertical. And then there's also a 440 Yagi right there.
Mm.
And then over here is the satellite array with the 440 and the 2-meter circularly polarized antennas. There's also a GPS timing antenna mounted right there. And yeah, this is kind of defunct. That doesn't mean anything. I'll have an active receive, DX Engineering active receive loop over there. And then, yeah, here's another view of our tower with the Skyhawk beam. And then this is our 440 repeater antenna right there. And then this is our fan dipole for 40 meters and 80 meters. And so the mast I showed you before is over there, and there's another mast over there.
Cool. You got a lot of
Yeah.
stuff.
And this is the guy who was in charge of installing all of it.
Don't fall off.
Yep, don't fall off. We have he did a nice radio frequency radiation study as well, and made sure things are appropriately signaged. There's our roof penetration.
Wow.
He said it was over 5,000 feet of coax. I think it was mostly LMR 400. So yeah, that's our station. And I also think he did a really nice job with the lightning arresters too.
Wow.
Could people please mute when you're not on? We're getting a lot of feed through.
See if I can mute everybody. So that okay. So before we go on, I think the things that I would like to cover in the agenda. First thing I'd like to have a discussion about. I think it's really fantastic, George, that you were able to come up with a possible solution for the dropouts.
Dropouts.
Yeah, the
I can
dropouts.
demonstrate that right now if you want to do that now.
Yeah. Actually, I also, before we do that, I see Chris Zorman joined us. I was just wondering, Chris, did you want to say anything while you're on here?
No, I'm just going to listen, and I'm participating because I'm helping coordinate the local activities for the ham side, working with John, making sure that at an institutional level, everything runs smoothly. So I'll be just kind of spying on you guys for a while.
That sounds great. Would you like to introduce? That's great. Would you like to introduce yourself? Because many people probably don't know who you are.
Yeah, so I'm Chris Zorman. I'm Associate Dean for Research here at the Case School of Engineering. I'm a professor of electrical engineering, and I'm continually hounded by David Kasdan and John Gibbons to get my license. And they know I'm trying really hard. I also work with Nathaniel on the NSF grants that we have, including the one that's coming up where we're going to do stuff associated with the eclipse. So glad to be here.
What Chris isn't saying is that he is an officer of the radio club, and it's an interesting spot that he volunteered for, and it's an officer's position that he suggested we create for an interesting reason. And do you want to mention it, Chris?
No, you open the can of worms, so you go ahead and figure out how to describe it. I will say one thing. I suggested it for the betterment of the radio club and not for my own personal advancement. So,
and we're well aware of that, and we're very grateful, but it is to provide research administration skills, in particular for handling grant administration to the radio club, and for providing an interface between university administration at top level, the university president, university administration at the, so to speak, bottom level, the departments, and the radio club. So we're deeply appreciative, Chris.
And I will add one thing. In about, I don't know, 4 or 5 months, we'll have photographs of our new radio tower on the roof, right? David and John, and in those photographs, we won't see snow. We'll see bright, sunny, warm weather, because those towers are supposed to be installed starting May 1st.
And this is Chris's effort, and once again, we're deeply appreciative.
Thank you so much, Chris. And that's good because we at Scranton need people to talk to on the ham radio. And David, is it true that W8EDU is still holding open station nights, open shack nights on Thursday evenings?
We are, and we have so many members that we have added Tuesday evenings. We had a license session yesterday with 6 new techs and 2 amateur extra upgrades, including the club president. So say nice things to him when you see him next.
That's wonderful.
And we licensed another dean. We have 2 deans licensed. Chris has been beaten out by 2 of his colleagues. We are going to storm his office at some random date in the next couple of weeks to tell him to take out his number 2 pencil and take the test.
Treat him nicely. He's my new boss.
Also,
I think that's great. And what time are your open station hours?
we run roughly 7 to 9:30, maybe 6:30 to 10:30 or so. It varies, but in there.
Okay, great. Because I've talked to my wife and we have agreed that we're also going to be running open station hours here at W3USR Thursday evenings. from 7 to 9 p.m. ish. And that is in large part to coordinate with your open station hours. So
Good, and we'll give you some suggestions, interesting things to do to keep everyone engaged at an open station. Like
I like it. That sounds wonderful.
Good, good. We look
Yeah,
forward to
so
it.
thank you, David. Thank you, Chris.
Okay, and congratulations.
Thank you. So I want to get back to the George. And I want this to kind of be an open discussion. I think the New England Grape Group, you guys have been absolutely fantastic in really providing an invaluable amount of both of engineering support and now also science support. And I mean, if we didn't have your help, I don't know that we probably would not have gotten the results we got from the October eclipse, getting that big deployment out. I mean, I can't even say, it's just been so fantastic.
Very kind words.
It was fun.
They're not enough words, I'm afraid, but I'm glad they're kind. I think one of the things that I think there's a lot of things about Hamside that work out really nicely. I think we've gotten a tremendous amount of participation and engagement from the amateur community at all levels, locally, nationally, internationally. We've gotten a tremendous amount of attention. I think amateurs are very good at setting up equipment. They're very good at collecting data. I think there's a lot of really good engineering work that amateurs do. But one of the goals of Hamsci is to advance science. And one of the tricks there is this whole idea of like peer-reviewed publications.
Right.
And that's incredible. I think it's incredibly time consuming. I don't know that it's necessarily harder per se than a lot of the things people are already doing if you know what you're doing, but I think it's incredibly time consuming because a lot of the things that make it hard include, paying careful attention to detail, just knowing how to structure and write things, knowing what to pay attention to. And then going through the whole rigmarole of the peer review process and getting it submitted to the journal and getting it there's just a lot of nitpicky stuff. And
yeah, back and forth with the editor.
Back and forth with the editors, and even now it's like making sure that the data is archived onto data archives and things like that. And I think the thing is we're now starting to see some really good, really interesting science contributions that are being shown at the Hamsci workshop. So we're like, if you look at the Hamsci workshop presentations, there are a number of presentations that I'm like, I think that could really be written up and published in a journal if it were done right. And same thing, I think, with this particular finding regarding the MUF. I think if that were written up correctly, I think that could get published in an appropriate journal. And I think the problem right now is we don't have enough scientists, to do all of the writing. And like, I'm working on a paper right now, which I can show you for my traveling atmospheric disturbance project. And like, just, I'm up nights and weekends trying to get that done in addition to doing all of this. So I guess what I'd like to see, I'd like to get your thoughts on how do we get citizen scientists first of all, are citizen scientists actually interested in publishing in peer-reviewed journals? And two, if so, what would be the best way to help guide them towards doing some of this publication?
I have written lots of specification documents in the computer industry, and I'm pretty good.
Yeah.
Mrs. Derrick, my 12th grade English class, made sure of that. So I have published elsewhere, and I'm a very picky editor. But you're absolutely right. It's a lot of work, and for someone who's never done it, it's jumping into the deep end.
Mm-hmm.
I've written some white papers, and I've written more proposal inputs that
Government
I would
proposals,
like to, but we won some of the proposals, so I guess that's,
yeah, government
But,
proposal.
but somebody's got to check my spelling and and my grammar.
Would,
I think the challenge might be it's kind of a chicken and egg situation. One, it'd be nice if we had identified the mentors that could help the citizen science community succeed in this realm. But at the
Mhm.
same time, you need the citizen science to step up and volunteer. So got to figure out how to make those two meet.
well, I'm volunteering to be a mentor.
That's one. That's great.
I couldn't
I
think
guess-
of a better one.
I guess I'm curious, would the New England Grape Group be interested in trying to lead or write a paper that might go into like radio science?
I think so.
Nathaniel, I have one suggestion that might help. One thing that might help push things along a bit would be to put together an outline for a particular project, but for an outline that's been successful before, that shows the general, okay, here's your introduction, and here, I mean, like
How to write a document, how to write a
yeah,
publishable
like the
paper.
template, Nathaniel, like the template that you have for doing a poster,
Sure,
Mhm.
kind of like that.
Sure.
I have that actually.
Yeah, so that's where to start, I think.
Yeah.
gotta have a executive summary at the top, although it's called something else in the science.
Called an
literature.
abstract.
Abstract, that's right.
Yeah. Mhm.
But yeah, there's an art to it as well as science.
Yeah.
So, Nathaniel?
Yeah.
So one thing you could do, I think maybe you already have it, is I like the idea of that outline, because the outline is actually what is going to frame the paper.
Yep.
Create a general outline and then apply it to a recently published paper that you were the lead author on. And you map then the components of the outline to the components in the paper, so people can see how the outline is actually then kind of rendered into writing. This is what I do with my graduate students, and that's part of their training. And I think that would be very applicable here, because I think citizen scientists will be really good at the technical stuff, but it's that upfront introduction, the background, the relevance to the scientific community where they might need some more coaching, and you have great papers on that already. But if you don't provide that outline framework alongside the paper, they might not see how to construct a paper of their own.
I think that all makes sense. Another approach that I found to be very successful. One thing that pretty much everyone has told me is that to write a paper, you start with the figures.
The illustrations, you mean?
The figures.
The illustration.
The illustrations. But
then you describe them.
And then you describe them, and those figures have to have a point.
Yeah.
But yeah, so I think maybe combining those two things of both, and then the third thing I found is that in making all of my papers have started off as conference presentations. So it's like I'd come up with a conference presentation. My conference presentation would also have an introduction, a methodology, a results section, and a discussion and a conclusion. So you kind of have that outline built into your conference presentation. And then as I go through a number of conferences, I'd keep iterating on that. And then one day we say, okay, today is the day. The presentation's good enough. Now let's actually write it up for publication.
Let's print it. Yeah.
Yeah. So I think the thing that's nice about this, and I can probably start writing some of this stuff down. The thing that's nice about this idea of the drop off is, at least for the papers that the space physics community wants to see, the space physics community in the NSF, they generally don't focus so much on like they don't really care per se about propagation for propagation's sake, and they don't care per se about communicating from one place to another for communication's sake. Like that's a nice broader impact, but they really care about like what the physical mechanism is underneath. And And so here's a case where we can go explain our system, explain what the grape is doing, and then we can point to something that we are observing. And I think we can actually potentially point to a physical mechanism that's causing it.
That would be cool. Let's see if
Yeah.
I find my. Where's my, oh, this one? No. I have another window here somewhere. Ah, yes, here. Now, this was the plot that Bill Blackwell sent out last night. He conglomerates FLDigi readings from, and this is what he calls the Northeast group. And it's not just people in the Northeast. Well, I guess it is. This green line is me. And most of these are at 10 megahertz, except for W1XP's in Groton. He's the brown line. He's at 15. And we got a nice big dropout there.
Yeah.
And everybody at
that's-
10 was
That's
fine.
the band closing.
Yeah. But let's go look at the other map I have. These are the, where am I? KC2G MUF maps, MUF maps. Oh, geez, stop that. This is the one I want. For yesterday as well. And we can go forward. Also, this over here is my signal strength in North Chelmsford, Massachusetts, near Boston. And we can just kind of see things progress. And there are glitches. Now this line here, what is that line? That's 14
ISO
megahertz.
line.
That's 14 megahertz. So 15 megahertz, that's too high to get from Colorado to here. And 10, here's a 10 bubble up here, but it really, I bet you, is never going to come down near us or near the in-between. No. So my signal strength remained very strong. And we did not see. Geez. You know, I hate computers.
Let me interrupt, please.
Sure.
Nathaniel, my apologies, but I have an appointment I have to make. And so
It's
I'm
quite
gonna
all
have
right.
to, I'm gonna have to leave. So, well, I'm sure we can discuss this or online or something. But I think there's some interest here.
I think that sounds really good.
Okay.
Yeah, the map we
70
saw
quick,
last,
everybody, but I just gotta leave.
yeah, the map
Okay,
we
good
saw
luck,
last,
Bob. Thank you.
the map we saw last week showed the 10 megahertz dipping in, and it correlated very nicely with the 10 megahertz WWV dips. So very good
Are you-
correlation.
Yeah,
Are you
last,
able to show the same correlation on the eclipse day?
no, I've only collected those KC2G maps since January 1st. Every 15 minutes I grab one.
Does he keep them?
I keep them.
I know, but does
can
he
you-
have a
Or does he?
repository?
I don't know.
Can you email him and ask?
I will do that.
Okay. Because I bet if you could see it in this day, you could probably see it on the eclipse day too.
Oh yeah.
And
I've got it
And I
just,
can-
it's just a little shell script that loops and waits 15
Yeah.
minutes and then does a scream job.
yeah,
And it runs forever. Do while true. And it's on my FLDigi Grape, even as we speak. But that's all part of something that's very dear to my heart, which is can be summed up in the visual display of quantitative information. It's
you sound like Edward Tufte.
exactly, that's the name of his book. That's the name of his book. And it was that's how to communicate this stuff. Make it
Right.
visible.
Right. I completely agree.
Makes it intuitive.
Yeah. So back to Ned.
That sounds good. All right, so I guess in terms of that discussion, we will, I think, so the next thing you're going to do is you're going to look and see if you can show the same thing for Eclipse Day, right?
For the past Eclipse Day or the next one?
The past one.
I will call up Mr. What is his name?
Andrew Rodland. And please send him my regards.
I will.
Yeah, he's got an email address on qrz.com. That's what I'm going to use. So
Okay,
Yeah.
I'll use that.
Do you, yeah. And then another thing I think we should do to help support this is to start building out a PowerPoint presentation that tells our story. Because that's the thing you want to do with the papers. You want to tell a story.
Oh, sure.
So I have the templates for the Hamsci workshop. Do you have that already?
What? No,
Yeah.
no, I do not.
Would you like me to give you the template?
Are you suggesting that I make up a presentation?
Yeah, because that's the first step to this, really.
Yeah, I hear you.
Because that presentation is actually the outline. The outline of the presentation is the same thing as the outline of the paper. But when you put in the presentation, you are also, it's very easy to add in the visual elements.
You expand it. I understand.
Yeah. So
Okay,
I can do
send me
here.
send me what you have.
Yeah,
Please.
I will show it to you right now. I can show the group right now, so it's I'm just
I was
looking
afraid you would
for it.
ask me this.
Ask and you shall receive.
That's right. Okay, so this is gonna be the 2024 Hamsci workshop presentation templates. Look at that. I have the presentation templates right here. And what I can do is I can start one up. I will start one up for this particular project. I've got to go to the right folder here. Bear with me for a minute. Here's my science folder. Okay. So New England Grape Group, HF dropout presentation, Hamsci workshop 2024.
Now I have a question.
Yes.
It's really not a dropout. It's that the propagation has changed and the angle of refraction has changed for some reason.
Right.
And as we see that stop motion animation, we can see areas of where the refraction has changed for particular frequencies, and it sort of moves like a fluid. And I'm saying, is this electron density or what is this that's moving? You can and what is being refracted? Is this the extraordinary wave or the ordinary wave or both or neither? Because if you look at the associated Doppler shift for the same station, no, it doesn't dip. So there's something getting through, and there's something reflecting still. And it's not some different path necessarily, I guess, because it's right along with the others. So what's the science behind what's going on up there?
Well, that's what we're going to learn as we write this paper.
You tell us, George.
So that's the other thing. It's the other trick with these papers. So far with the papers I've written, we start off, we see something, we have some sort of observation. We try to lay that out as clearly as possible. And then after we have that, then we have to go through the process of explaining why it's happening. So that really is
why we think it's happening, why we posit that it's happening.
Right. And we need to provide evidence as to why we think it's happening.
Correct.
So we have a number of ways of Well, here let me let me email this. I'll just put in the OneDrive share. So anyone apply, copy link can download. So here I'm gonna put this link in the chat. And then anyone who wants the template can go ahead and download it.
Dooby. Thank you, sir. Copy link, Bob.
So one of the things you could possibly do with the combination of the map and our grape data is to predict where you wouldn't see any dropout.
That's correct. I have often looked at the nightly plots from Bill Blackwell and said, oh, we didn't get a dropout. Okay, so let's look at the maps and see why we didn't get a dropout. I haven't done
But that'd be another nice application of the same principle. So
yeah, but I haven't done that. Where is my paste? Why didn't that come? Copy link, paste. Presentation title, author 1. Okay.
So here's a presentation I've been giving recently about the festivals of eclipse and atmospheric science. And so you can see I have the whole co-author list over here. So you're able to add in a bunch of people. But yeah, so in this presentation template, every paper, it has an introduction. You're going to have a methodology. You're going to have results. And the results is where you observe the particular thing. So it's like, that's the part where we see this dropout and you want to be able to show systematically how you see it. And then after the results, you're going to have a discussion section. And the discussion section is where you interpret the results and kind of you explain what they mean and what you think is causing it and why and how that advances the state of our knowledge.
Understood. As I said, have a background in this. I've got a bachelor's in EE and an MBA, and I have done tons of papers.
Yeah.
So thank you for this.
Yeah, and the other thing I've talked about that I think we're going to want to apply to this is we have access to these models. So this is a model of the October eclipse. It's a model in the ionosphere.
Oh yeah, nice. Nice graphical display.
And we have this is actually a 4-dimensional model, so 3D spatial plus time. And then we have the ability to run ray traces where you can set particular frequency and we can predict how the radio wave should be going through that model.
And this is an interactive tool that I can play with?
Well, yes, you can play with it. It's probably more difficult to use than you would like it to be, because it does involve a lot of like coding and things like that, but it is available to you. We also have.
It's okay with coding. I taught a 4-bit microprocessor to take square roots.
Perfect.
Wow.
So we have graduate students that can help you to run this.
Actually, it wasn't square roots, it was standard deviations.
Yeah. So so this software is available, and yes, you can run it yourself. Wing Griffiths, who's going to be our guest speaker on this afternoon's call, he runs this code. And we also have students, you can ask people like Rachel Bodeker to help you run plots and make plots because we'll want her to be a co-author on the paper as well. And I have another student who's working with doing a lot of development with PyLap and FarLap right now. So basically we have tools that we can, we can look at the observations and we can then model it and use those models to help validate our hypothesis.
Got it. Oh. On here.
I think it's probably good to go on to another topic now. I think this is really good.
Where's the agenda?
The agenda, well, I'm kind of going off the top of my head agenda. The next thing that I wanted to hear from with John Gibbons was the Grape 2 status. And are there any emergencies that we need to address or anything like that?
Actually, it's been a very busy week for me. The biggest thing and the biggest takeaway from last week's meeting, and it was sort of a dumb moment for me and a very significant learning experience that you don't ignore the facts, is sampling at or folding the 1 kilohertz carrier to 500 hertz. I invariably was causing aliasing from the 500 and 600 hertz tones that are on the AM carrier. And in fact, the 600 hertz tone with a 500 hertz center would wrap it to mathematically minus 100 hertz, which shows up physically in the spectrum as 100 hertz phase inverted. And that's what happens when you alias things like that. So I actually got lucky. One of my first guesses with the Grape 1 at putting it at kilohertz works fine for WWV, but did not for WWVH. The 1200 hertz tone is going to wrap around to 200 hertz. Fortunately, it was not in our bandpass. It didn't cause any problems. But now that I understand that, and I now have purposely put the WWV carrier at 1600 hertz. And the reason I did that is 1600 is an even multiple of my 8 kilohertz sample rate, specifically is 5 times. And that was the one advantage I also had with the 1 kilohertz, because that was a multiple of 8 kilohertz at 8 times. So having that helps the math a little bit, because now we have an even number of multiple cycles in our sample period. So by putting that there, it moves the center frequency to 15 to 1600. I now put the 500 hertz at 1100, the 600 hertz at a kilohertz, and it also allows for the 1.2 kilohertz ticks for WWVH to show up at 400 hertz. So I went through and very quickly we did all the frequency mapping. Fortunately, Bill had the foresight to put this in a table that we could put it into Excel and just change the numbers to come up with all the frequency division ratios for the 5351 synthesizer. He has implemented those and they're actually running on my bench at home right now. We just started that up and the testing's looking pretty good. So was sort of a major breakthrough for me, because now I understand why we put it there and what we're getting around and what we're fixing. So the aliasing was a real problem and we did fix it. Fortunately, it was just firmware. Don't hit me, Bill.
Thank you.
Oh, I needed that.
Merely a matter of coding, as my boss used to say.
Yeah, it's just code. What's the problem? But so that's been taken care of, and I'm going to be validating it was 5 times 6. I had to come up with 30 different frequencies, because I'm also doing basically a frequency plot for my AC testing of the test fixture for validating the RF decks. Like I said, last week I went through and there were 20 analog DC points that I measured on all 36 boards, and they all passed, which I was really happy about. But the next test is to run the AC signal through and verify AC functionality of the RF deck, which is going to be probably tomorrow's project. So that's on deck. As far as the logic boards at the board house, they got a hold of me yesterday. There was a couple of part discrepancies, and I caught one problem where I had purchased the wrong package. For the 74 HC74s, I had bought SSOP packages and not the 14 SOIC packages. Fortunately, I had 300 of them sitting around that I'm going to be dropping off at their facility this afternoon for the board build. And those are due to be finished on the 24th of this month. And then it's coming up with test fixtures and testing protocols and testing to test those boards. And once those plug together, then we're ready to start assembly. The code, Bill has been working on this significantly nasty bug that's got really sharp teeth. And I think we finally squished it. It's basically, in a nutshell, when you're doing synchronous data acquisition on an extremely rigid time schedule, anytime you have an operating system that's scheduling things, sometimes things can back up, and it had the fingerprint of it. Every now and then it would back up and the buffer overflow between the Pico and the Raspberry Pi would get out of step and we get a buffer failure. We've done some things. Bill's done some significant coding around trying to fix that, but we've been fighting this bug for the last 6 to 8 weeks. And I think in the last 4 days, we finally got successful runs where that hasn't happened. So we're in the final phases of putting that one to bed. We've also decided that the status monitor really has to call the data acquisition code because we don't want the consumer to have root access to the program for obvious security reasons, because they could really mangle the system if something goes wrong. So we're controlling that. Kung is working on that with the status monitor, being able to call these things and the data collection and all that kind of stuff. So that's going rather smoothly. The initial status monitor data screen is working, although we do not currently have any live data for the magnetometer yet. And we're making the magnetometer an option that when the system is started up on the setup program, we're going to go out and we're going to ping the address. If it's there, we'll include that on the screen in the data set. If not, we won't. It looks like I should be able to get at least 10, actually about 20 of the outside magnetometer units from Dave Witten. He has them built. I have 4 of them in my greedy little hands that we've been testing to test the interface. Since the interface is already built onto the Grape 2, it will do the magnetometer automatically. And that's actually one of the final coding tasks for Bill Blackwell, is to get that going and work with another data pipe in the OS to talk to get that stuff in, because it comes in an I2C. So that's moving ahead. Trying to think what other major events happened. I think at this point,
I'm sorry, just a question. Was the problem that was bugging you, was the bug that was bugging you for so long?
It's basically an issue with
the message loop wasn't fast
basically we have a pipe of data between the Pico and the Raspberry Pi that have this fire hose of data coming in. But the problem is that it's coming off of a synchronous process. And to understand it, the reason we cannot do the data acquisition on the Raspberry Pi is because the OS has a septic and it also schedules tasks to get moved around. They sort of smush around to allow themselves to run.
Yeah.
And with a synchronous acquisition, every 125 microseconds, I must have the CPU to take the data.
Yep.
And if you're in the middle of a DMA transfer cycle on a disk transfer, you miss it. And that completely screws up our process, which is why I had to go to a dedicated processor to do the actual data processing. And even with 4 cores, we were running into problems at every 125 microseconds that the data was not able to get pushed up to the Pi.
The message loop wasn't fast enough.
So we've actually dedicated a core on the Pi that all it does is receive data and nothing else. And there's a core dedicated, I believe, on the Pico doing the same thing. Yeah. And with that and running it at 100% on the Pico and playing some tricks with that Bill is, this level above me on firmware, we're actually getting it to work. But this is not your standard, we've got a 44 kilohertz audio stream coming in, we're recording it, no problems at all. No, this is a completely different ballgame. People don't understand that synchronous data acquisition is a complete different ballgame than asynchronous data acquisition.
Yep.
So, But we've actually got it to work, and I'm actually gonna hand it over to Bill now because I have to think of what else I forgot. So take it away, Bill.
And just, and so you know, I unfortunately have a hard stop today at 11 a.m.
Okay.
So I may have to drop out, but so go ahead, Bill.
well, not much to add, except, it's taking the real-time problem from the Pico and moving it up to the Pi, and the Pi is not a real-time OS. So, we need to play some tricks with the CPU affinity and making sure the thread runs on its own dedicated CPU. And, I'm still, experimenting with separating the writer thread from the reader thread. Right now, they're one thread. I'm gonna keep working on this in my spare time. So, but any other issues, John? I don't think we really have. I mean,
I think we're in good shape.
Process control area with StatMon. Maybe we should call it the Grape 2 console or something now instead
That'd
of.
probably be a good idea. Yeah, we'll talk about that this afternoon.
Yeah, that will start and stop the data controller, the data acquisition, and maybe also the magnetometer reader. So that's it for me.
Yeah, the other thing I just remembered is I put together a board set and a case mechanical sample. Put it all together. I stuck the Leo Bodnar on top, the Raspberry Pi on top, the cabling to the Raspberry Pi, put it all together with the cables on the RF deck and everything, and I shipped that to Majid at Scranton.
Yes.
Yeah. And he has it in his possession. I shipped to him. He got it Saturday morning, and he's doing the 3D front panel. And he's also doing, the way the box is set up, it has rails on the top that we can slide a rail on top that's going to hold the Raspberry Pi and the cables that run to Leo Bodnar and the Leo Bodnar on top of the case. Then that whole assembly will be sitting on top of the disk drive. So we'll have a nice unit that's all there to run the Grape system, the Grape 2. So he's working on getting 3D models. I told him tentatively we'd like to be able to at least print front panels by the end of the month so we can start assembly. Because like I said, I'm supposed to have the second board set in a week from today. And then I start testing. Hopefully that'll go quick, and then we can start doing board assembly, and I'll start coordinating what's going on with that. The only other crisis that we're working on now is that Western Digital canceled our hard drive order on December 12th. And it was at their factory that they canceled it and said that the address was incorrect. So I think there was something else going on. Either they had another customer that they needed to get it to, or the box is too heavy for shipping, or whatever it was. But we've got that reordered, and hopefully it will be showing up here for my signature. But that's the last real component I have to get are the 35 4 terabyte hard drives. I have the cases for them already, and I'm looking to try and power that 12-volt case off of the Grape 2 power supply, so there's only one wall wart. But worst case, if that doesn't have the enough overhead in the supply to do that, we'll have 2 wall warts for the Grape 2. That's the worst case scenario. So Kung, are you on here? Yes, you are. You have any updates, Kung?
Do have just in addition to what you have already said about the status monitor, well, I mean the Grape 2 console now.
Yeah, we're working on that.
Yeah, I think it's time I refactor what my existing code, because using right now with the curses library is a very low level library that I have to pinpoint the specific coordinates on the screen to print out the data. And that is not a very, very maintainable way of designing an interface. So I would have to refactor that, unfortunately.
Well, for the first shot out of the barrel, we're probably going to stick with that because we don't want to start something new right now. We will definitely do that after the April 8th. It's just a matter of timing and all that kind of stuff. Because since we have one now working, I don't want to mess with it.
Unfortunately, it isn't working anymore, as your recent email have shown. So
we'll talk about that this afternoon.
Yeah. Okay, sounds good.
So, work in progress. coming together. I probably will be trying to assemble an assembly team. Like I mentioned last week, Gary came here and put together the 35 grapes into their cases with the cables. The next major assembly is going to be, well, I'll be testing the boards and plugging them together as a set. We'll slide them into the case, screw them to the front panel, and tie the Raspberry Pi on and the Leo Bodnar and cable it all together. And then we'll start making copies of the 32 gig micro SD distribution for the nodes and start figuring out how we're going to distribute that. So it's coming together. I got one more major task that I'm going to have done here, and I may pull Gary in on this, and that's when we get the drives in, we have to repartition them as ext4 one partition and give them a label of G2 data, which is pretty straightforward. It's just plug, type it, plug, and going on and on. So I may lean on Gary again for his significant help. He's been a big help for that. So kudos to Gary for chipping in on that. That's helped me a lot.
Yeah. Want to just mention the need for, at some point, having beta testers.
Yes.
Start running the software.
Yeah, and those beta test units will be coming out in red cases because I got different colors. So
ooh, fancy. I'm gonna head off. I'm gonna head off for now. I can leave do you want me to leave the recording running, or do you want to?
I think I'm pretty much done. So
I'll be back on for the 4 o'clock telecon this afternoon. And I know we have Gwen Griffiths is a special guest today, talking about the how the eclipse might affect propagation between the US and the UK. So I think that's going to be a really interesting presentation. I'm really looking forward to it. And Gwen has also indicated that he's interested in coming to the Hamside workshop in person this year. So cool. I'm super, super excited to hopefully see that happen. So I guess I'll stop the recording. I'll leave the Zoom room open. You guys keep chatting, but I will say 73 for now, and thank you so much.
Before you go, you have sent me this presentation outline, neg HF dropout presentation, blah blah. But I can't edit it.